Safety, stress, and vigilance. How urban environments consume attention and restrict action. Imagine a person crossing a wide urban junction with a small child. The pedestrian signal turns green. The person steps forward, but the movement is not automatic. First, they check whether vehicles approaching from the left have actually stopped. Then they look over their shoulder for a driver turning right. They hold the child's hand more tightly. Halfway across, they notice that the countdown has already begun. They increase their pace. A vehicle is waiting across the pedestrian path. Another vehicle enters the junction before its exit is clear. The child moves toward a damaged section of pavement. The adult pulls the child sideways, checks the signal again, and tries to predict whether the approaching driver has seen them. Nothing happens. They reach the opposite sidewalk. From the standpoint of collision statistics, this was a safe crossing. Nobody was struck. No injury was recorded. The police received no report. From the standpoint of behavior, however, the crossing imposed a substantial burden. The pedestrian had to monitor several moving threats, interpret an ambiguous signal, control another person's movement, adjust speed, and prepare for other people to violate the rules. The journey was physically possible, but it demanded continuous defensive attention. This lecture examines the difference between being able to move through a city and being able to move without excessive vigilance. Its central argument is, safety is not merely the absence of collision or injury. It is the degree to which people can act without devoting excessive attention to protecting themselves. This does not mean that perceived safety is more important than actual danger, nor does it mean that fear always represents objective risk accurately. It means that urban behavior is shaped by both. A street can produce few recorded collisions because people avoid it, cross elsewhere, restrict children's movement, or remain constantly alert. A place may therefore appear statistically safe, partly because it has successfully frightened vulnerable users away. To understand this, we need to distinguish danger, risk, perceived safety, stress, and vigilance. Danger refers to conditions capable of causing harm. Risk concerns the probability and potential severity of that harm. Perceived safety concerns how secure or threatened a person experiences the situation to be. Stress concerns the relationship between environmental demands and the person's capacity to respond. Vigilance is sustained attention directed toward detecting important or threatening events. These concepts overlap, but they are not interchangeable. A fast-moving vehicle is a source of danger. The probability of conflict depends on speed, distance, visibility, and many other conditions. A pedestrian's perception of that risk depends on experience, uncertainty, trust, bodily capacity, and responsibility for others. The need to monitor the vehicle consumes attention. If the demand persists, the journey becomes stressful. Urban safety is therefore not only an engineering question about collision probabilities. It is also a behavioral question about what people must perceive, anticipate, and do in order to prevent the collision. One of the foundational figures in stress research was Hans Selye. In his 1936 paper, A Syndrome Produced by Diverse Nocuous Agents, Selye described a general physiological response to different harmful conditions. His later work developed the concept of the general adaptation syndrome, commonly described through alarm, resistance, and exhaustion. Selye helped establish that different stressors could produce broadly similar bodily responses. But his model concentrated heavily on stress as a physiological reaction. For urban behavioral analysis, the transactional approach developed by Richard Lazarus and Susan Folkman is often more useful. In Stress, Appraisal, and Coping, published in 1984, Lazarus and Folkman argued that psychological stress does not lie only in an external event or only inside a person. It arises within a relationship between person and environment. The important question is whether environmental demands are appraised as taxing or exceeding the person's available resources. They distinguish two connected processes. In primary appraisal, a person evaluates what a situation means for their well-being. Is it irrelevant, beneficial, challenging, or threatening? In secondary appraisal, the person evaluates what can be done. Do I have enough time? Can I control the situation? Is there a safe route? Can I rely on other people? Can I escape or obtain assistance? Consider a simple street crossing. A healthy adult walking alone may appraise the crossing as manageable. The same person now pushing a stroller may appraise it differently. A child may lack the perceptual skill to judge vehicle speed reliably. An older pedestrian may know that the green phase is shorter than their ordinary walking time. A wheelchair user may see that the opposite curb ramp is blocked. The external junction has not changed. The relationship between demand and capacity has. Stress is therefore not proof of personal weakness. It may be evidence that the environment demands too much regulation from the person. This is particularly important when people are responsible for others. A caregiver does not monitor only personal safety. They must regulate the movement of a child, anticipate sudden actions, inspect surfaces, judge traffic, and maintain control of bags, bicycles, or strollers. The same crossing produces several simultaneous tasks. The additional burden is easy to miss because much of it is cognitive rather than visible. We can call this burden an urban attention tax. The phrase does not refer to a formal psychological measurement. It is an analytical metaphor for the attention that an environment repeatedly demands simply to make ordinary action possible. Daniel Kahneman's 1973 book, Attention and Effort, treated attention as a limited capacity that can be allocated across competing activities. Earlier, Donald Broadbent's work on selective attention had examined how people filter information when more arrives than can be processed effectively. These theories differ in important ways, but both point toward a basic constraint. Human attention is limited. When one task consumes more of it, less remains available for other tasks. A pedestrian who must watch turning vehicles has less attention available for conversation, orientation, social observation, or noticing the surroundings. A cyclist monitoring doors, potholes, buses, and unpredictable lane changes has fewer resources available for relaxed exploration. A parent supervising a child beside fast traffic cannot give the same attention to the child's questions, discoveries, or attempts at independence. The attention tax does not necessarily stop movement. Often it changes the quality of movement. People walk faster. They stop talking. They hold children more tightly. They avoid eye contact. They choose direct routes. They abandon browsing and exploration. They hesitate before crossing. They avoid traveling at certain times. The environment remains technically usable, but only under concentrated self-protection. This distinction matters because conventional transport assessment often records whether movement occurred, not what the movement demanded. A person completed the route. A child reached school. A cyclist passed through the junction. The behavior is recorded as evidence that the route works. But successful passage may reflect human adaptation to poor design. Competence can conceal environmental failure. Vigilance research helps explain why continuous monitoring is difficult. During the Second World War, Norman Mackworth studied the ability of radar operators to detect rare signals over extended periods. His experiments showed that performance in sustained attention tasks declines over time, a pattern commonly called the vigilance decrement. A city street is not a laboratory clock or radar screen. Urban movement includes bodily action, changing information, and multiple goals. Still, the general lesson is relevant. Sustained monitoring has costs. People cannot remain equally attentive to everything for unlimited periods. This creates a fundamental safety problem. Many urban environments require users to monitor rare but serious violations. Most drivers may stop at a crossing, but a pedestrian must remain prepared for the one who does not. Most journeys may pass without conflict, but the cyclist must continue checking for the suddenly opened door. Most signal phases may function normally, but the older pedestrian must consider the possibility that the phase will end before they reach the other side. This is not simply fear. It is risk management under uncertainty. Uncertainty is often more behaviorally important than average performance. A bus that usually arrives within 10 minutes, but sometimes disappears for 40 minutes, is difficult to build a routine around. A crossing where drivers sometimes yield and sometimes accelerate requires more attention than one governed by a stable convention. A sidewalk that occasionally ends without warning demands advanced route checking. Reliability allows attention to relax. Unreliability keeps the person in a monitoring state. This is why rule compliance matters beyond the individual event. When drivers reliably yield, pedestrians learn that the crossing can be trusted. When signals consistently protect pedestrian movement, people need less defensive interpretation. When sidewalks remain continuous, users can direct attention toward destinations and social life. Reliable environments reduce the number of questions a person must answer at every step. Will that driver stop? Will the route continue? Can I reach the opposite curb? Is the lift working? Will a vehicle appear from behind me? Must I run before the signal changes? Every unresolved question consumes attention. Perceived safety is sometimes dismissed as subjective. That is a mistake. Subjective does not mean imaginary. Perception is the process through which people decide whether and how to act. At the same time, perception is not an infallible measurement of objective danger. People may fear rare events and underestimate familiar ones. They may become accustomed to hazardous conditions. Cultural expectations, recent experiences, and visible cues influence judgment. Risk researcher Paul Slovic showed that perceived risk is shaped by characteristics such as dread, familiarity, controllability, and uncertainty, not simply by numerical probability. In urban settings, perceived control is especially important. A person may tolerate a demanding environment when they believe they can predict and manage it. Stress increases when important outcomes depend on actors whose behavior is difficult to anticipate. A narrow path beside a physical barrier may feel safer than a wider painted lane because the barrier reduces uncertainty about vehicle intrusion. A pedestrian refuge can make a long crossing more manageable by dividing one complex task into two. A raised crossing can increase confidence because vehicle speed is constrained physically rather than merely requested by a sign. Good safety design reduces the amount of trust that must be placed in perfect behavior. This is one reason the distinction between objective and perceived safety should not be framed as a contest. The goal is not to choose one. A street should reduce actual danger and communicate that reduction through conditions people can perceive. A concrete barrier may provide protection, but if the route is poorly lit and visually isolated, some users may still avoid it. A space may look orderly while vehicle speeds remain dangerously high. Feeling safe without being safe is inadequate. Being statistically safe while feeling unusable is also inadequate. The two measures reveal different failures. The relationship becomes particularly complicated when avoidance removes exposure. Suppose parents consider a road too dangerous for children to cross independently. They drive their children instead. The number of child-pedestrian collisions remains low. An analyst might conclude that the road presents little documented danger, but the low collision count does not demonstrate successful child mobility. It may demonstrate the disappearance of children from the street. This is sometimes called a denominator problem. Collision counts depend partly on how many people walk or cycle and how much exposure they experience. If few people attempt an activity, few incidents may be recorded even when conditions are hostile. Avoidance is therefore a safety outcome. So are detours, escorting, schedule changes, and abandoned journeys. Research on children's independent mobility makes this especially visible. In One False Move, published in 1990, Mayor Hillman, John Adams, and John Whiteleg documented the decline of children's independent travel and adults' growing control over their movement. The central issue was not only whether children reached destinations, it was whether they possessed licenses from parents to cross roads, travel alone, and move beyond immediate supervision. Adult escorting can reduce a child's immediate exposure to traffic while also reducing independent mobility. This produces a paradox. The environment appears safer because adults absorb the risk management task, but the cost is transferred into parental time, household scheduling, car trips, and children's lost independence. The safety problem has not disappeared. It has been privatized within the family. Different users also experience different vigilance burdens. Children have less experience judging traffic and may direct attention toward play, conversation, or immediate objects. Older people may require more time to cross and may be more concerned about falling. People with visual or hearing impairments rely on different sources of information. Wheelchair users must monitor surfaces, slopes, and accessible exits before committing to a route. A person pushing a stroller must consider curb transitions and the child's position in relation to vehicles. Someone unfamiliar with the area must navigate while also monitoring safety. Gender, previous harassment, time of day, and social identity can shape which people or places are treated as potential threats. There is no single urban safety experience. The same environment distributes different monitoring tasks to different users. Designers often describe these users as vulnerable. The term can be useful, but it can also misplace responsibility. A child is not inherently a traffic problem. A wheelchair is not inherently an access problem. Vulnerability is partly produced through the relationship between bodily characteristics and environmental conditions. A street designed around high-speed vehicles makes the unprotected body vulnerable. Change the speed, geometry, priority, and separation, and the relationship changes. Environmental stress also extends beyond immediate traffic conflict. Gary Evans's research examined chronic environmental stressors including noise, crowding, traffic congestion, pollution, and poor housing conditions. This work showed that environmental stress can have cognitive, motivational, and physiological consequences, even when people appear to have adapted. Adaptation is not necessarily the absence of cost. A person may report that they have become used to traffic noise while still experiencing interference with concentration, communication, or restoration. People can learn to ignore environmental information, but filtering also consumes resources and can reduce sensitivity to other signals. Noise is behaviorally important because it changes what actions a place supports. Conversation becomes harder. Children must stay closer to adults to be heard. People raise their voices. Quiet activities become less attractive. Warnings may be masked. A street can remain physically accessible while becoming socially and cognitively thinner. Traffic volume can also reshape social behavior. Donald Appleyard and Mark Lintell's 1972 study compared 3 similar residential streets in San Francisco with different traffic levels. Higher traffic was associated with lower perceived livability, less social interaction, reduced territorial extent, and weaker environmental awareness. Appleyard's later livable streets developed the argument that streets should be understood as social environments and resident territories, not merely channels for movement. This research is sometimes reduced to the claim that traffic produces fewer friendships. The deeper behavioral point is that traffic changes the conditions under which social contact can occur. People are less likely to stop when conversation is difficult. Children's play requires closer supervision. Crossing to speak with a neighbor becomes more demanding. The opposite sidewalk begins to function like another territory. Noise, danger, and interruption weaken the small, repeated encounters from which familiarity develops. Stress, therefore, does not only affect individual well-being, it can alter collective street life. An environment organized around vigilance leaves fewer opportunities for lingering, improvisation, and low-stakes social contact. This connects safety to attentional narrowing. Under demanding conditions, attention tends to concentrate on information relevant to the immediate task. That can be adaptive. A pedestrian facing unpredictable traffic should watch vehicles rather than admire a facade. But when attentional narrowing becomes the ordinary mode of moving through a place, the person encounters less of the city. They notice fewer details. They explore less. They may not stop, play, converse, or change directions spontaneously. The route becomes a corridor to survive rather than a place to inhabit. This helps explain why safety influences affordances. A street may physically afford crossing, sitting, or play, but if actualizing those possibilities requires excessive vigilance, they become less usable. The possibility exists in a narrow technical sense while disappearing from ordinary behavior. A bench beside fast traffic still affords sitting physically, yet noise, exposure, and uncertainty may prevent it from inviting rest. A child may be physically capable of walking to school, but if every junction demands adult-level threat monitoring, the route does not afford independent travel reliably. Safety is therefore not an additional feature applied after accessibility. It partly determines whether available actions can be actualized. Repeated stress also shapes habits and mode choice. Suppose cycling requires negotiating the same hostile junction every morning. Initially, the rider may approach it cautiously and consciously. After several frightening encounters, they may change route, travel at another time, or stop cycling. The resulting behavior may later be described as preference. The person prefers driving, but the preference has developed through repeated experience. The environment has trained avoidance. The same process operates in parental decisions. A parent walks with a child once and encounters speeding traffic, blocked sidewalks, and short signal phases. The next morning, driving appears easier. After repetition, driving becomes routine. The city then observes high car use around the school and interprets it as demand for more drop-off space. A stressful environment produces avoidance. Avoidance produces traffic. Traffic reinforces the stressful environment. The system begins to manufacture the behavior it later treats as spontaneous choice. How should safety, stress, and vigilance be studied? Collision data remain essential, but they are not sufficient. They identify recorded events, not the full behavioral burden preceding them. Exposure data are also needed. How many people walk, cycle, or cross at the location? How often? Under what conditions? Observation can record defensive behavior. Do pedestrians hesitate, retreat, run, alter direction, or wait for another person before crossing? Do cyclists dismount, move onto the sidewalk, or avoid a junction? Do caregivers physically reposition children? These verbs reveal how people manage the environment. Route choice studies can identify avoided streets and preferred crossings. Walk-along interviews can reveal what users monitor and anticipate. Participants can identify places where they feel compelled to hurry, where they stop conversations, or where they refuse to let children travel independently. Eye tracking and physiological measures can contribute evidence about visual attention and arousal, although neither should be treated as a transparent window into experience. A higher heart rate does not explain by itself what a person is feeling. Looking at a vehicle does not prove fear. Measurements require interpretation within the activity and context. Natural experiments are especially valuable. Researchers can compare behavior before and after a speed reduction, protected crossing, traffic filter, lighting change, or signal redesign. The question is not only whether collisions change. Do hesitation and running decline? Do more people cross? Do children gain independent mobility? Do people linger longer? Does attention shift away from constant threat monitoring? A strong assessment should therefore examine at least 4 dimensions: actual danger, perceived safety, behavioral adaptation, participation. Actual danger asks how likely and severe harm is. Perceived safety asks how people experience and interpret the situation. Behavioral adaptation asks what they must do to manage it. Participation asks who appears, who remains absent, and what activities occur. These dimensions can move in different directions. A barrier may reduce actual traffic danger, but create difficulty for some mobility devices. A new signal may increase formal protection while imposing a long wait that encourages informal crossing. A route may become statistically safer because walking declines. A street may feel more comfortable while hidden hazards remain. No single indicator can carry the whole analysis. Several common mistakes follow from ignoring these distinctions. The first is equating no recorded collision with safety. The absence of an event does not reveal how much avoidance or vigilance prevented it. The second is dismissing perceived safety as irrational. Perception may be imperfect, but it directly shapes action. The third is treating adaptation as proof of successful design. People can become highly skilled at surviving bad conditions. The fourth is assuming that all users face the same attentional task. A person walking alone and a person guiding a child do not encounter the same crossing. The fifth is blaming vulnerable users for vulnerability created by speed, geometry, and exposure. The sixth is relying on education where design should reduce danger. Teaching a child to look carefully cannot compensate for a junction that requires monitoring several conflicting vehicle movements at once. The seventh is confusing warning with protection. A sign communicates information. It does not physically reduce speed, shorten a crossing, or prevent intrusion. The eighth is treating stress only as a feeling reported after the journey. Stress can appear through route changes, hurried movement, withdrawal, and reduced participation. The ninth is measuring only successful users. The people absent from a street may be among the most important evidence. The 10th is designing for perfect attention. People become distracted, tired, hurried, and overloaded. A safe system should not require flawless vigilance from every person at every moment. We can now return to the opening junction. The person and child crossed without injury. But we no longer describe the episode simply as successful movement. We examine the number of threats that required monitoring. We ask whether rules were reliable. We observe the tightening of the hand, the increase in walking speed, and the repeated scanning. We ask whether the child could cross independently. We consider whether the experience will alter tomorrow's route or transport mode. We investigate who does not attempt the crossing at all. The deepest point is not that cities should eliminate every demand on attention. That is impossible. Movement always requires perception, judgment, and adjustment. The question is whether the demand is proportionate, predictable, and fairly distributed. A well-designed street still requires awareness. But it should not require ordinary users to operate as unpaid air traffic controllers merely to reach the opposite sidewalk. Safety becomes visible when people no longer need to organize every movement around possible failure. A pedestrian can continue a conversation. A child can notice something interesting without creating immediate danger. An older person can walk at an ordinary pace. A cyclist can direct attention toward the route ahead rather than constantly checking for intrusion. A caregiver can guide rather than physically control. These are not decorative improvements to mobility. They are evidence that the environment has reduced the cost of participation. The final questions are therefore not only how many collisions occurred. We must also ask, how much attention does safe passage require? Which violations must people anticipate? How predictable are the rules? Who must hurry, hesitate, detour, or seek assistance? Who has stopped making the journey? Whose time and attention absorb the failure of the system? Can children, older people, and disabled users participate without exceptional skill? Does the environment reduce danger physically, or merely ask people to be more careful? And what forms of urban life disappear when everyone must remain vigilant? A safe city is not one in which skilled people successfully avoid injury. It is one in which ordinary human fallibility does not carry an unreasonable price. It allows people to move without constant defensive calculation. It supports attention, but does not consume it. It permits awareness without demanding fear. And it makes safety part of ordinary action rather than an achievement that must be won at every crossing. Selected original works cited Appleyard, Donald. Livable Streets, University of California Press, 1981. Appleyard, Donald, and Mark Lintell. The Environmental Quality of City Streets, The Resident's Viewpoint. Journal of the American Institute of Planners 38, Number 2, 1972, pp. 84 to 101. Original article, please open your app to see this link.